Hello everyone. In this video, we are going to discuss about the topic and the concept power. Power is defined as the time rate at which the work is done or energy is transferred. For example, consider a person of mass 50 kilogram climbs up a staircase of 20 steps in 30 seconds. And another person of the same mass 50 kilogram climbs up the same staircase of 20 steps in 20 seconds. Then who has more power? The second person has more power than the first person. Why? Both are climbing up the same staircase, so work done is the same in both the cases. But the time taken to do that work is more for the first person and less for the second person. That is, the second person climbs up faster than the first person, so second person has more power. So, power is defined as the time rate at which the work is done or energy is transferred. The average power is defined as the ratio of the work to the total time taken. That is W work done divided by time. I am taking this as equation number 1. The instantaneous power is defined as the limiting value of the average power as the time interval approaches 0. So we can write that instantaneous power as dW divided by dt, and I am taking this as equation number 2. Let dW be the work done by a force vector F for a displacement vector dr. dW is the work done by a force vector F for a displacement vector dr. Then the instantaneous power becomes what? Instantaneous power P is equal to vector F. What is dW by dt? No, what is dW? What is dW? Work done is equal to vector W is equal to vector F dot vector D, no? Dot product of force and displacement. So dW is equal to vector F dot the displacement vector dr. So work done that becomes dW by, power is equal to dW by divided by dt. What is the dW? Vector F dot vector dr then divided by dt. Okay, now what is this d vector r divided by dt? Rate of change of displacement. It is the velocity, no? So we can write power is equal to vector F dot vector v. I am taking this as equation number 3. See, power, it is a dot product of force and velocity. So, power is a scalar quantity. Here, vector v, it is an instantaneous velocity, and vector f is the force. Okay, now, what about the dimension of power? Dimensions of power is actually equal to dimensions of force into dimensions of velocity. Dimensions of force, mass into acceleration of mlt raised to minus 2. Dimensions of velocity, lt raised to minus 1, which we have studied in in our previous chapter, in the second or third chapter, no? So, mlt raised to minus 2, lt raised to minus 1. This is equal to what? Dimensions of power is what? M, then L square, t raised to minus 2, t raised to minus 1, that is t raised to minus 3. So, this is the dimensions of power. Now, the SI unit of power is watt. It is represented by capital letter W. Okay, now we have power is equal to work done divided by time, no? So, power P is equal to work done divided by time. SI unit of power is watt, so I am writing it as 1 watt is equal to SI unit of work done is joule, so I am simply writing it as 1 joule or joule, no problem with that. Then SI unit of time is second. Okay, so we can write 1 watt is equal to 1 joule divided by 1 second, or 1 joule second raised to minus 1. So, 1 watt is equal to 1 joule second raised to minus 1. Now, there is another unit of power which is horsepower. Okay, horsepower, it is represented by HP, and 1 horsepower is equal to 746 watts. Okay, because SI unit of power is watt, another unit of power is horsepower. This unit of power is actually used to describe the output of automobiles, motorbikes, etc. So, 1 horsepower is equal to 746 watts. When we buy electrical appliances such as refrigerators, bulbs, mixer, etc., we encounter the unit watt. So, if we have a bulb of 100 watts and if it is on for 10 hours, how much energy would it use? Okay, we have a bulb of 100 watts and if it is on for 10 hours, how much energy, electrical energy would it use? We have power is equal to work done divided by time now. This work done can be considered as the energy consumed. So energy consumed is equal to what? Power into time. Okay, now what is that power? Energy consumed is equal to power into time. Power 100 watts. So 100 watts into time 10 hours. Okay, so this is equal to 100 into 10, 1000 watt hour. Okay, 1000 watt hour. Now 1000 watts is actually equal to kilowatt. Okay, 1 kilowatt is equal to 1000 watts. So 1 kilowatt hour. Alright, so here the energy consumed is 1 kilowatt hour. So kilowatt hour, it is actually a commercial unit of energy. Alright, 1 kilowatt hour. Kilowatt hour, it is not the unit of power, it is a unit of energy. It is a commercial unit of energy. Then 1 kilowatt hour is equal to 1 kilo means 1000. Okay, kilowatt means 1000 watts. Then 1 hour means 3600 seconds now. Okay, 1 hour 60 minutes, 1 minute 60 seconds. So 60 into 60 is 3600 seconds. So this will give you 36. Then 5 zeros are there. 3 2. Okay, 5 zeros are there. That is equal to 36 into 10 raised to 5 watt second. What is that watt second? Watt second is actually joule. You can see from here watt second, watt into second is equal to joule. So this can be written as 36 into 10 raised to 5 or you can write it as 3.6 into 10 raised to 6 joule. Okay, so kilowatt hour, it is a commercial unit of energy. It is not the unit of power. So in this video, we have discussed about the concept of power. I hope you understood this. Thank you.